Okay. Let's review what we talked about from 6.1. Okay, the image is the second figure. After the transformation. The pre-image then is the first figure the original before the transformation. The scale factor is equal to the image divided by the pre-image. It tells you how much bigger you made the image or how much smaller you made the image. Okay, congruent figures. You learned this back in Math 1. Okay, and congruent figures are two figures are congruent if and only if the second can be obtained from the first by a sequence of reflections, translations, and rotations. Congruents have all corresponding parts are congruent. So all the corresponding angles are congruent. All of the corresponding sides are congruent. In Math 1, we discovered that we only need 3 parts to guarantee the 2 triangles were congruent. Either you could prove that all the sides are congruent through side, 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 or an angle and their included side, 2 angles and their included side, angle, side, angle, or there's also angle, angle, and then side. So we want to prove that these 2 triangles are congruent. I'm going to do that. If they are congruent, we're going to describe the transformations that are needed to prove they are congruent. Okay, so first we'll say that triangle ABC is congruent. We need to find what goes along with angle A. So here's my angle A. What angle corresponds to angle A in triangle? So angle A goes with angle F. Then angle B corresponds then to angle D. And that means angle C corresponds to angle E. The next thing we're going to deal with is how we could get triangle ABC to be over triangle FDE. There's more than one way to do this, so if you can see a different way than what I'm going to show you, that's fine. You can transform this in any way as long as it can get to where we're going. Or if you go in a different order, that's fine too. I'm going to reflect my triangle across the y-axis to begin with. So I'm going to do first. To do that, I fold my paper along the y-axis, and so B has to be 2 away on the other side. And so this is my new B, B prime. C then should be 3 away. So 1, 2, 3 would be C for me. Then A would be 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6 away. And this will be A. And these are all prime. I'll draw it in. Like so. Okay. Then I can reflect this across the y equals 3 horizontal line. So this would be 1, 2, 3, 4 above. This would be 1, 2, 3, 4. Okay. And this would be A double prime now. Then this would be 1, 2, 3, 4. This would be 1, 2, 3, 4. C double prime. And then C prime is on it, so it would be stay there. It doesn't reflect at all, it just stays. So C prime is the same thing, C double prime. So that's my new triangle. We're almost there, we're not quite there yet. We still need to go now up 1. So we're going to translate triangle A double prime. Oh, that should be B. This is B double prime. B double prime, and then C prime. because it didn't change at all. And we're just going to translate it up 1 unit. And now it should lie right over triangle FDE. That proves that those two triangles are congruent. Now this year we're going to focus on similar figures. And similar figures are slightly different than congruent figures because they're not exactly the same. They're the same shape with bigger in size. So it's a scale model. So if you talk about architectures and they make scale models of whatever they want to build, this is how they do it, through similar figures, through the proportions that we do. So similar figures, two figures are similar if and only if the second figure can be obtained from the first by a sequence of rotations, reflections, translations, and now what we are currently talking about, which was dilation. Okay, so we're going to try and figure out if the two triangles are similar, and if so, what transformations are needed to prove they are similar. So we're going to start by writing a similarity statement, which is triangle ABC is similar. That is the similar symbol. Just so you know. To triangle. And again, we need to find those corresponding angles. This is pretty easy. A goes with D, and then B goes with E. And then C goes with F. Any questions over that? Then we go on to the transformations. So first thing we should do is just shift it. I'm going to move B to where E is, so I just need to move that to the right. 1, 2, 3, 4, 5, 6. So B goes where E is. And then C is going to move over 6. 1, 2, 3, 4, 5, 6. And then A is going to move over 6. 1, 2, 3, 4, 5, 6. So my new triangle is here. Now we can just dilate it. By 2. So I just take the distance here and measure it. So that's the length of it, and I'm just going to move it over here. Oh goodness. To show that it's this length here. And then I'll do the same thing here, measure this. And notice that it's just the same distance here. So now this can lay right on top. Okay, and that's the Me proving that triangle ABC is similar to triangle DEF. Okay, so now we want to determine if the following conjectures are true. Remember, conjecture just means hypothesis, just math. Are all rectangles are similar? So if we draw a rectangle, okay, and then we draw another rectangle. Are those two rectangles similar? They do all have right angles. They do all have right angles, so all the angles are congruent, but are the sides necessarily proportional? And that would be no. Not all rectangles are similar. Only if the corresponding sides are proportional. Because this could be like 4 here, this would be 4. Let's say this is, you think that's 6, this is 6. Well, this could be 6 and 6 here, but this could just be 5 and 5. So your proportion with 4 and 6 is not equal to your proportion with 6 and 5. And you would need those proportions to match in order for this to be proven to be similar. All squares are similar. Okay, so we're going to draw a square. I'm going to draw another square. It's hopefully a little bit bigger. Okay, and so we have all the angles are congruent because they're all 90 degrees. So that part of it just works. But are the sides proportional? So what if I said this was side 3? That means this also has to be 3 and 3 and 3. And what about this side being 5? Then this would have to be 5 and 5 and 5. So if we had our corresponding sides, 5 and 3, or 3 So if we put our corresponding sides of 3 and 5, is that equal to the other corresponding sides of 3 and 5? And that is, those are equal, so all squares are similar. We could do this a bunch of times, but since all the sides are congruent, you're going to always have that same proportion all the way around. Okay, how about all equilateral triangles are similar? So So let's try and draw an equilateral triangle here. Okay. And so these are equilateral triangles, and this is all the sides are going to be equal. That also means that all the angles will be 60 degrees. Because there are 180 degrees in a triangle, and all the angles have to be congruent if all the sides are congruent. So 180 divided by 3 is 60. So I have, let's use 4 this time. And then this would be 6. And just like the square then, my corresponding sides, 4 over 6, and then this 4 over this 6. Those are all equal to the same ratio of 2/3. Okay. And it would be the same with the base side of 4 over 6. So this is proving, and if I did this with a bunch of different other equilateral triangles, it'd be the same idea. All the sides would be the same proportion. So then all equilateral, oopsie, triangles are similar. How about all rhombuses are similar? Okay, remember a rhombus is just a parallelogram with all sides congruent. Okay, so let's see if we can draw a bigger one here. Ooh. This rhombus isn't necessarily equilateral, or this is not necessarily a rhombus. Let's try that again. It kind of looks just more like a parallelogram. Looks like more, a little bit more like it's all sides are congruent. Okay. So we could have this be 3, 3, 3, 3, and this be 6, 6, 6, and 6. Okay. So all my sides are necessarily congruent and proportional. So 3 over 6 would equal 3 over 6. But would all the angles necessarily be congruent? I don't necessarily can't prove that this angle is going to be congruent to this angle, or this angle is going to be congruent to this angle. Okay, so not all rhombuses are similar. Only if their corresponding angles are congruent. Okay. Okay, in the following information, can you prove the triangles are congruent or similar? Two triangles with 3 corresponding angles are congruent. Okay, so I want you to try those ones on your own. 2 triangles with 3 corresponding angles are congruent, and then 2 triangles, oh, it says it the same thing. Okay, so to see if these are congruent or similar, and how can you prove either one? This should say 2. 2 corresponding angles are congruent. Okay. Try to come up with those ones on your own. And we will go over them in class. Okay, the next one is just checking to see how we do with this. Given the similar figures, identify 3 different ratios that would be equivalent. Okay. So we're going to start with these 2 triangles. Triangle, this is the similarity statement. Triangle ABC is similar to triangle DEF. And so to find that, we're going to start with AB. Here's AB. And AB goes with the first 2 letters in the second triangle, which is DE. So we have our first ratio, 7 over x. Then our next 2 letters are BC and EF. Here's BC, which is 4, over EF, which is 3. So this is our scale factor. Okay. And we're just going to use our scale factors. They don't give us a pre-image and an image, but they just give us the first one, ABC, is similar to DEF, so that's how we'll do it. ABC over DEF. And the last one would be A to C and D to F. So this side would be 5 over D to F would be Y. So those are my 3 equivalent ratios. And if we wanted to, we could find X and Y, and we'll show you how to do that. So we're just going to take our 7 over X and set it equal to our scale factor, which was 4 over 3, and then cross multiply and get 21 equals X times 4, which is 4X. We're going to divide by 4, and that'll give me X equals 5 point. 5.25. Okay, we do the same thing to find Y. We use our scale factor of 4 over 3 and set it equal to the ratio with Y, 5 over Y. Cross multiply, get 4Y equals 3 times 5 is 15. Divide by 4, divide by 4. And we're going to get Y equals 3.75. Okay. Now the polygon, this one's a little bit more complicated because there's a lot of sides. So again, just find one of the sides. Here's BC. BC are those first two letters, and MM, we're going to be there. So it's going to be 3 over the y. Then our next one we find is CD, and those are right there. So we're going to do ML. The letters need to be in the same spot on the similarity statement. So it needs to be 2 over 4. And you don't need these, I don't know why this is here. So you don't need those quotation marks there. So for that similarity statement. Okay, so this is our scale factor. We would just reduce it to 1/2. And again, this is our scale factor. Okay. Then we would do the next one we could find, which would be EF, which are the last two letters, so QP. So that would be 3.5 over X. And that's all we can do with those, because of the 3 different congruency statements we can make. Okay. Again, if we want to, we can find the y and the x. 3 over y equals 1/2. Cross multiply. Get 6 equals y. And then we could do it with the 3.5 and the x ratio. Again, you want to use your scale factor, have 3.5 over x, and then cross multiply. Get x equals 2 times 3.5 is 7. And that's how you can find them. Okay, so your homework is, the next one is the 6.3 worksheet in your other packet. It's just 1 page front and back. So we'll work on that. You can work on that homework, or if you're period 4, you can work on it in class on Tuesday.